Hi there, so here we go. Now that we know all about the LCD, we can now start practicing adding and subtracting rational expressions. So always when we're adding and subtracting rational expressions, we have to first find the LCD. And this one is pretty easy, right? Okay, so now we're just going to write each of these over the LCD. This is kind of what we were doing at the end of the last video. And so we ask the question, what do I multiply this by to get this? And the answer is x plus 1. So that's what I multiply the 2 by. Same thing here, I have to multiply the 3 by x minus 1. So now I have a common denominator. And if I multiply out, I get 2x plus 2 plus 3x minus 3. And if I simplify that, I get 5x minus 1 over x minus 1 times x plus 1. And there's my answer. And that's a basic idea of how you add. And obviously subtracting is just exactly the same. So it's all about finding the LCD. If you can find the LCD, that's the whole heart of solving an addition and subtraction problem of rational expressions. Okay, so let's work through this problem. And in this case, the first thing we have to do is factor the bottoms. Difference of two squares. And on this one, it's a trinomial, and it factors as x plus 3, x minus 2. Okay? So now that the denominators are factored, we need to find the LCD. So take a stare at that and see if you can write down what the LCD is. Okay, did you get this? Okay, so now we're going to add these two things together with the LCD. I'm going to skip a little step here. I'm going to write the whole thing over x plus 3, x minus 3, x minus 2. And what does this 2x have to get multiplied by? So when you look at the original, and then you look down here, what did it get multiplied by? Can you pick it up? It looks like it got multiplied by x minus 2. Okay, and then we have that plus 5. And what is the 5 getting multiplied by? Looks like an x minus 3. Okay, so now I'm going to multiply everything out. And let's see, do you think I can fit it in here? I'm going to give it a shot. So my denominator, x plus 3, x minus 3, x minus 2, and I get 2x squared minus 4x plus 5x minus 15. Okay, that fit pretty well. So now if we combine like terms on the top, it looks like we get 2x squared plus x minus 15. Got to keep writing this bottom. So it's x plus 3, x minus 3, x minus 2. Okay, and so now what's the next step? Yes, you guessed it, we got to factor the top. So we'll leave the bottom all alone. X plus 3, x minus 3, x minus 2. Check out these wild colors, huh? Pretty cool. And so you might want to press pause and see if you can factor the top. And it factors like 2x minus 5 and x plus 3, right? And so now we can cancel out any common terms, which is an x plus 3 and an x plus 3. And so our final answer looks like 2x minus 5 over x minus 3 times x minus 2. And there we go. And so that is a fairly difficult problem of adding these two rational expressions. All right, so we'll look at one more, and that'll be it. Okay. So this is a fairly complicated one. We got some addition and some subtraction going on. And so what we need to do, as always, is factor the bottoms completely. And there's really only one bottom that needs to be factored. So let's do that. Okay, so here I've factored that difference of two squares. And now when you try to figure out what the LCD is, it's just r plus s times r minus s. And so what we're going to do is take these three things and write them all over r plus s times r minus s. So this 2r stays alone, and this 1 gets multiplied by r minus s, and this minus 1 gets multiplied by r plus s. And so what we get is 2r plus r minus s minus r minus s all over the bottom. And if we simplify the top, what do we get? Can you see it? We get 2r minus 2s over the bottom. And we can factor that as 2 times r minus s over r plus s times r minus s. And finally, we can do a little bit of simplifying here. And so our final answer is 2 over r plus s. So, as I said before, it's all about getting the LCD and writing each expression over the LCD, because you can't add or subtract unless the denominators are exactly the same. Okay, so there we go. That's adding and subtracting.